طيب, what we are going to talk about today, we will talk about the IPv6, Internet Protocol version 6. So before we start talking about the IPv6, let us have an introduction. Why IPv6? Why IP version 6? Simply, we have talked about the 5 regions. Last class, we have allocated a global IPv4 for each region. Then it will be the responsibility to reallocate that IPv4 to the ISPs, and the ISPs can allocate it to their customers or subscribers. However, what's the problem with IPv4? It's limited. It's only 32 bits. Simply, we are running out of addresses. 4 out of these 5 regions running out. No more global IPv4 addresses available for any new service required to be connected uniquely over the internet. So in order to handle this issue, we have the successor اللي هو خلينا نقول الخلف للIPv4, which is the IPv6. So IPv6 is the successor to the IPv4. It has a larger number of bits on the address space. How many bits we have? 128 bits. So how many different or possible IPv6 unique address we can have? 340 followed by 36 0. So the number is 340 and decillion actually. So also, it's not simply an IPv6. There are many enhancements included to fix the limitation and the problems of the IPv4. For example, one of the enhancements in IPv6, as you will see today, inshallah, because we are going to talk about the ICMP, the Internet Control Message Protocol, is the ICMP version 6. It will include some additional enhancements, such, for example, address auto-configuration or address resolution, which was not found in ICMP version 4. So with this increasing of the internet population, limited space for IPv4, many issues related to the NAT, Network Address Translator, and the IoTs, the Internet of Things, means we have a huge number of devices, not only computers connected to the internet, they need a unique IP address, smartphones, tablets, whatever. So it's the time to move. To move to what? To IPv6. So we will not say it's the time to move. It's the time to the transition. We will transition from IPv4 to IPv6. So now, how the transition will be carried on, will be performed. We cannot stop 4 and start immediately using and depending on IPv6. It's totally incorrect in this case. So both IPs, version 4 and 6, will coexist in the near future, and the transition will take several years, which means after several years, no, we'll shut down all the IPv4 and only we will use IPv6. Now, Internet Engineering Task Force, IETF, has created a different or various protocol and tool help the administration to migrate their network to IPv6. Now, the migration techniques here can be divided into 3 categories, which means how we will run IPv6 and IPv4, and after that will depends only or will use only IPv6. First method or first migration techniques is called dual stack. Dual stack simply, The devices will run both, will have both IPv4 and IPv6 protocol stacks running simultaneously at the same time. And this is actually the current situation. So we can call it, or it's known as native IPv6, which means any customer or any device with IPv6 connection to their ISPs, they can access the content of the internet by using the IPv6, not 4. 6, not 4. Second migration method is called tunneling. What's the tunneling? Now, we are not going to explain it in full details. It's out of the scope. Just we need to know the concept. Tunneling, simply, it's the method of transporting IPv6 packet over an IPv4 network. So the IPv6 packets is encapsulated inside version 4 packets. Give us an example. I have two networks and gateways. They're using a dual stack, or IPv6 they use. So they need to communicate with each other across the internet. On the internet, we have only IPv4. So in this case, we can use the tunneling, who will encapsulate version 6 packets over or into a version 4 packets. Last migration techniques, translation. Translation, network address translator, NAT. It's not services, but 64, not the ordinary NAT we talk about it. So translation, network address translation, 64 allows enabled devices with IPv6 to communicate with IPv4 enabled devices using the translator technique similar to the translation techniques we talk about when we covering the NAT for IPv4. Now, finally, keep in your mind that tunneling and the translation are for the transition only to the native IPv6. So they should be used where needed only. So what's the main goal? The main goal to have a totally native IPv6 communication from the source to the destination. When we will achieve this? On the coming future, not in the current situation, but this is the plan. Now, how the IPv6 will be represented? Please focus here, okay? We have agreed, or we know that the IPv6 is 128 bits length. So we will not write it on the binary notation, or we will not use the decimal notation. What we will use, it will be represented or written in the hexadecimal. This is the first comments. Second point, exactly, Ahlam, hexa. Second point, keep in your mind that IPv6 are not case sensitive, insensitive, which means we can write it either in lower case or uppercase, and they will consider the same without any problem. Now, third comment is the important one. The preferred format for writing the IPv6 is divided into a group of hexet. Divided into a group of hexet. Each X here is a hexet, actually. And each X as a hexet here contains four hexadecimal numbers. Each one 4 hexadecimal numbers. So how many bits the total? 4 hexadecimal numbers. So how many bits per hexet? Each X is 4 hexadecimal numbers. So we have 16 bits. Thank you so much. We have 16 bits per hexet. So the preferred format to writing the IPv6 is to use this X notation separated by colon, consisting 4 hexadecimal values. So each X is a hexet. But keep in your mind, hexet is an official term used to refer to the segments of 16 bits or 4 hexadecimal value. It's an official term used to refer to every 16 bits to each 4 hexadecimal values. So let us take an example about the preferred format. We have an IPv6 address. We have another one. So each X is what? It's a hexet, 4 hexadecimal values. Each X is 16 bits, containing 16 bits, 4 bits per hexadecimal number. So the 2, if we want to convert it to binary, 0, 1, 0, 0. The next 0 as a hexadecimal, 0, 0, 0, 0. Next 0, 0, 0, 0, 0. The 1, 1, 0, 0, 0. 4 bits per hexadecimal number, 16 bits per hexet. واضح? Is it clear? Before we continue. طيب, now, as you see here, we have, let me say, a lengthy IPv6 address. Can we rewrite or re-represent the IPv6 in more abstracted or compressed format? Yes, we can rewrite it and reduce the length, compress it. In some way, we can say we can compress the IPv6 address. Now, how? We have 2 rules. The first rule is called emit leading zeros. What does that mean? Any zeros on the left of the hexadecimal number will be removed. At the left, not at the right. So the first step to represent the IPv6 in more abstracted or compressed or compact format is called the leading zero. Delete the leading zero. What does that mean? For example, if we have this hexet 01AB, it can be represented as 1AB. It's still what? 4 hexadecimal numbers. Okay, 16 bits. But it can be represented without the leading zero. But if it's like this, if we have 1A, B, 0, we cannot delete this 0. We cannot. Why? It's not a leading. It's a trailing 0 here. Okay? So one more example, 09FO or F9. It will be represented as F9F0. 0A00, A00, 00AB. It can be represented as only AB. What if I have 0000? How we can represent it? We can use a single 0. We can use a single 1. It's already here. For this hexet, we have a single 0. For this one, we have a single 0. And for this one, we have a single 0. If you check the Net Academy, you will find about 10 or more exercises, smart interactive exercises about how to re-represent the IPv6 by using omit leading zero rule. So, for example, if we have this IPv6 address, let us apply the leading 0 rule. 2001 will not be changed. Now we have 0 db8. We have one leading 0. It will be omitted. We have 4 zeros. It represented as a single 1. We have 4 ones. Nothing will be done. 4 zeros, a single 0. 4 zeros, single 0. 4 zeros, single 0. Now 0 200 200. واضح هذا؟ Any question here? Type. Now we have a second rule, and here please focus. It's called the double colon. Double colon simply can replace any single or contiguous يعني خلينا نقول متسلسل string of one or more 16 bits hexets consisting only zeros. So one more time. If I have multiple hexets and these hexets containing only zeros, it can be represented only by using the double colon. And we'll see an example. Now, for example, if we have this. Now this one, already the zeros omitted. Now check here. I have a 3 contiguous zeros, 3 hexets. So how we can apply the double colon rule? Simply, they will be represented with a double colon. So the IPv6 address will be written in the final compressed way as 2001 db8 cafe 1 double colon, which means I have omitted or replaced zeros. Hexets, it can be a single one, it can be 2, contiguous, 3, 4, sometimes 5, and the last hexet 0001. Now, how the question might be, they will give you the IPv6 and ask you to write it in the compressed format, or the compressed format will be given and they will ask you to rewrite it by using the preferred format. Now be careful. I have some comments here about the double colon rule. Only it will be used one time within the address. We can use it only one time within the address, which means if we have more than a single series, for example, as you see here, we have zeros and we have another zeros. We will use it only one time with the largest one. Let me say, with the largest one. So if we have more than one contiguous string of zeros, the best practice is to use it with the longest one. Now, what if we have more than a string of zeros and they are equally in size? They have the same size. What we'll do in this case, the first string of zeros, take it and replace it with a colon, double colon. So only single string of contiguous zeros will be replaced. If we have more than one, take the longest one. If they are equally in size, the first one. Take the first one on the left side. So if this one double zero, and we have another zeros, so which means, for example, if the address will be like this, if the address is like this, in this case, what we will do? In this case, we'll take this as a first, and what we will do with this one, we'll apply the omitting 0 rules. 0, 0, colon. Only one, a string replaced with 00. Any question here? في أي سؤال؟
لا شكرا، الله يعطيك العافية.
لا. طيب. الآن let us talk about the IPv6 addresses types. We have many types or multiple types for IPv6. First type is unicast. We have multicast address. We have anycast IPv6 address. So 3 main categories for the IPv6 addresses. Unicast is the same as the unicast with an IPv4, which means it will be uniquely identifies an interface on the IPv6 enabled devices. Every interface should allocate a unique IPv6 address. Now, multicast, multiple devices, belongs to the same group. So it's one-to-many, but not all. Remember, this is the multicast. So multicast is used to send a single IPv6 packets to multiple destinations. These destinations will be a part of the same multicast group. They will be assigned to the same multicast group, and we'll talk about it later on. What's the IPv6 address will be used for the multicast group. Now, a new one is called anycast. So what's the anycast? Anycast is an address, simply will be assigned to more than one interface. 3 servers or 4 servers providing the same service, local web servers, let me say, will be assigned the same IPv6 address. So this address will belongs to different nodes. Same address, a single address will be assigned to more than one interface. So if you want to send anycast packet will be sent to the anycast address, and it will be routed to the nearest interface that has that address. So there is no problem to duplicate the IP, and it will be routed to the nearest one. What we call this situation anycast address. Anycast address. So simply IPv6 is a unique address, but it will be assigned to multiple devices. Now it's not a group, it's a unique address assigned to multiple devices. So the packet sent on the anycast will be routed to the nearest device having that address. First address we find it with that anycast address will receive the packets. Now, for the IPv6, we do not need a broadcast address. There is an IPv6 address for all nodes multicast group address. We'll talk about it. That can be used to give the same result as broadcast address. All nodes address, we'll talk about it and we'll see it in the coming slides. Now, also it's very important to understand the prefix length. What's the prefix length of IPv6? How we will represent the IPv6? IPv6 will not use the decimal. dot notation for representation. Also will not use the subnet master representation 192.168.10.1/24. For example, subnet mask 255.255.255.0 will not represented in this way, but like the IPv4, the prefix length will be used and it's represented in the slash notation. Why we need the prefix length? To indicate the network portion of the IPv6 address. So it's very similar, let me say, to the prefix length of the IPv4. So a prefix length represents or represented on the slash notation and used to indicate the network portion of the IPv6. IPv6 prefix length can range from 0 to 128. Can take any number between 0 and 128 bits. Here we're talking about the bits. But it's highly recommended, listen to me carefully, to use the prefix with 64. It's recommended for the LANs and most other types to use the prefix with 64. What does that mean? If we have used this prefix, 64 bits will be used for the network, and the other 64 bits for the interface ID. The interface ID, as we can see in this example. Why we need the prefix? To identify the network portion, to indicate the network portion. Do not forget this. So it's strongly recommended to use 64-bit interface ID for most the network, because the stateless address auto configuration uses 64 bits for the interface ID. What's this? We'll talk about it in full details. How the device will either randomly or manually generate interface ID card for the IPv6 in this class. Also, it's recommended to use the /64 prefix because the subnetting process will be very simple to create and manage as well. You will see subnetting on the IPv6 is very simple, straightforward, easy process. لأن clearly prefix لأنه بدنا نعتمد عليه later on. واضح هنا؟ Do you have any question طلاب؟ طيب بالله ركزوا شوي. Now we have a unicast, we have multicast, and we have anycast. For the unicast, we have a different types of unicast address we have. So unlike the IPv4 devices that have only a single address, any IPv4 device will be allocated with a single address. IPv6 address or IPv6 devices usually or typically will have two, not one, two unique addresses. Two unique addresses, not a single one. The first address is called Global Unicast Address, GUA, and the second one, Local Link Address, which is for the local link within the same subnet. So Global Unicast Address, GUA, it's simply an analog or equivalent to the or similar to the global IPv4 address. So this is a similar to the public, not the global IPv4 address. These addresses are globally unique internet routable addresses. So this is the unique address simply. Now, local link address. We'll talk about it in full details now in the coming parts. It required every IPv6 enabled interface device. It requires for every IPv6 enabled device and used to communicate with other devices on the same local link. What we mean by the same local link? The same subnet. Same network. So we have a global address, we have a local communication address, we call it local link address. Local link address are not routable and are confined on a single link only. What I mean by a single link or local link, within the same subnet only, on a single interface. Every enabled device IPv6 address will have a global unicast address, local link address. Now also, it's not, let me say, it's not a private address. يعني خلينا نقول it's a private to be used within the same subnet only يا أحلام. هذا اللوكال لينك ادرس بنستخدمه إذا كان الديفايسز موجودين بنفس السبنت بتواصلوا مع بعض عن طريقه هو اللوكال لينك ادرس. يعني ما بدي استخدم الوورد برايفت، تمام؟ زي الاي بي اللي موجود عندي باللان تاعي تقريبا، خلينا نحكي، لانه نفس التاسك. طيب also we have the loopback address. Loopback address, as you see, they use the prefix 128. So we have all zeros, we have double colon and a single one. So what's the address of the loopback address? Let me say here in this case we have 127 0 and a single one. This is like the local link 172.10.0.0 or .0.0.1, I think. I forget the IPv4 address. We have unspecified addresses as a unicast. We have unique local address. I will talk about it now in next class slide. Embedded IPv4 address, which means inside the IPv6 address we have an IPv4, an embedded IPv4. We need to focus on the global unicast, local link, loopback, unique local address. Now, is it clear what does the global unicast and local link address means? What about now the unique local address? Unique local address simply can be used to address devices, and these devices will not be accessible from outside the network. For example, I have internal servers, I have internal printers. So I will give my internal servers and internal printers, internal only, a unique local address. Now we have a range for the unique local address. IPv6 unique local address range from FC00. What the prefix we are using here? We are using the prefix 7 for the network. Up to FDFF also within the prefix 7. You must know, because some of the questions on the final exam for the Net Academy, they will give you an address. Which type of address? The giving address. Is it a global? Is it a unique? Is it a linked local address? Is it unicast? So you need to know within or from the range. So this is the range used. Any IP started with FC and end with FD, FF within this range. So it's what? It's a unique local address. Now, request for common RFC standards 1918 private address. It's very similar to the private address for the IPv4, but we have three important differences between the local link address and the private address. First one, unique local address used for local addressing within the site between the limited number of sites, locally only. Unique local address can be used for the device that will never accessed from another network. Because of this, I told you it will not be accessed from outside the network. Unique local address are not globally routed or translated to global IPv6 address. Now, many sites use a private nature of RFC 1918 standard address to attempt to secure or hide their network from potential security risk. This was never intended to use in the unique local address. We do not want the unique local address to hide our network components and to protect it. It's simply use it to assign for a device and communication locally a unique address, unique local address, not for the security issues. Now, let us talk about the global unicast address. IPv6 global unicast address are globally unique and routable on the IPv6. This is the unique global routable address. Now, how many bits we have for the network? We have 64. And we have 64 for the interface ID. Actually, the IPv6 address will contain 3 fields, not 2. It will not be the prefix and the interface. The prefix will have a global routing prefix field, subnet ID field, and interface ID. The interface ID is 64 bits, according to the recommendation. Now, it's recommended also for the global routing prefix to be or to be assigned with a /48 prefix, which is a global routing prefix, which is the address will be assigned from the ISPs to their customers, for example. Now, what about the other 16 bits? Because 64 minus 48 equals 16. 16 bits, we will use it for the subnet ID. Now, this is the recommendation, but we can use a global routing prefix. It can be /32. So how many bits per the subnet? 64 minus 32, 32 bits for the subnet ID. Now, this one will be discussed also, the subnet ID. Now, what's the range of the global IPv6 address? Currently, we have only the first 3 bits of the first hexadecimal number of the first hexet are being assigned. Only the first 3 bits from one of the hexadecimal values on the first hexet have been assigned. So the range will be from 2000 with a prefix 3. How? Now check this one. We have used, this is the first hexet. We have allocated or used the first 3 bits only. So 0, 1, 0, 0. Okay, bit 1, 2, 3. Now convert this one to binary. What's the value of this one in binary? 2. 2. Simply zeros, zeros, 0. So this is the range. This is the first hexet, the first global unicast address. Now, last one, all the bits The other bits after the third bit will be 1. So 1, here the 0 will be 1, 1, 1, 1, 1, 1, 1. So these 4 ones, F, 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 F. Now what about this? It become 1, 1, 0, 0, 1, 1, 0, 0, 3. So it's started from 2, 0, 0, 0, 0 with the prefix 3, ended by 3, F, F, F. Any value within this, it's what? It's what? A global IPv6 address. Now, when we have assigned only, or currently we are using only the first 3 bits, which equivalent to the decimal number of 2, this one is only 1/8 of the total available IPv6 addresses space. It's nothing. We still have a huge IPv6 addresses. Now let us talk about the fields, the structure of the global unicast address. As you see, we have 3 fields. We have a global routing prefix, subnet ID, interface ID. Global routing prefix is the prefix of the network portion address that is assigned by the provider. Who's the provider? The ISPs. They will assign this prefix. And later on, we will generate a random or manually interface ID to have the fully unique IPv6 address, as you will see later. Now, the global routing prefix will vary depending on the ISP's policies. It can be 48, can be 32, it can be any length, but it's recommended. It's recommended to use the prefix what here? I said it's recommended to use the prefix 48. Subnet ID field are the area between the global routing prefix and the interface ID. Subnet ID used by the organization to identify a subnet within the task. So we can create 2 to the power 16 different subnet. On each subnet, we have 2 to the power 64 interface user or ID address from these 16 bits. In case we are using what? The prefix 48. Why this one is 16? 48 plus 16 subnet ID equal 64. And the 64 is what? The network portion actually, the prefix length in this case. The global routing plus the subnet ID. Interface ID is equivalent to the host portion. It's strongly recommended in most of the cases, okay, to be a prefix 64 subnet, which will create an interface ID with also 64 bits interface ID. Why? The prefix is 64, so 64 for the network, the global routing prefix and the subnet ID. The total length is 128, so 64 plus 64 is 128. Now keep in your mind also for the IPv6, it allows to use all zeros address and all ones. We do not have a broadcast address. Host address can be assigned on the device. All zeros address reserved as a subnet router unicast address and should be assigned only to router. All zeros, it's already reserved address for the subnet router as an unicast address. And it should be assigned to a router only. But we have all zeros, we have all ones. في أي سؤال الآن؟ طيب. Now let us talk about the local link address. As we said, IPv6 local link address enable devices to communicate over IPv6 enabled devices on the same link, only on the same link, and only on that link. What's the link I'm talking about? Only within the same subnet. So packets with the source and destination local link address cannot be routed outside the network. Every enabled IPv6 network interface must have local link address. If the local link address is not configured manually on an interface, the device will automatically create one. Also, if it's not configured, the device will automatically create one without communicating the DHCP server, the Dynamic Host Configuration Protocol. IPv6 enabled host create a local link address even if the device is not assigned a global unicast address. Even without a global unicast address, we can have a local link address. So in this case, we will allow for the enabled devices with IPv6 to communicate with each other over the same subnet. This also including the default gateway, the router, which will have a local link address for the local subnet as well. Now, what is the range of the local link address? Local link address are in the range FE80 with a prefix 10. So, for the first hexet FE80, let us see the binary representation F, 4 zeros. Now E is 14, 0, 1, 1, 1, 1, 8, 0, 0, 0, 1. And finally, we have the 0, 4, 0. To what? 1, 1, 1, 1, F, 1, 1, 1, 0. We will not change it. E. Now the B, this is the prefix, 10 bits for the prefix, 8, 10, to understand how we find the range. Now, only these 6 bits will become as zeros. I'm talking about the first hexet, okay? And the remaining can be zeros. So 1, 1, 1, 1, 1, 1. What is this? B, 11. 1 plus 2 plus 8, 11, B. What about the last one, 4 ones? F. So from FE80, the range, to FEBF. Is it clear how we find the range? So any address started with is what? What's the type of the address? Local link address.
Local address.
Any address start with 2000?
Global.
Global unicast address. Thank you so much. So router, let me say 1, will have a local link address communication with the router 2 on this interface. BC2 will connect with this router at this local link address locally within the same subnet. So every single interface will allocate it global unicast address, local link address. Routers now will use the local link address of a neighbor router to send the routing updates. It's a local connection. Host will use the local link address to connect with the local routers as a default gateway. Now for this host, this interface is the default gateway address for this host. So any internet connection should go through this local link address as a default gateway. واضح؟ Now, how we will configure.
بعد اذنك لو سمحت دكتور.
لحظة بس ارفع الصوت عندي، تفضل.
يعني الاي بي ادرس هو يحدد نوع الجهاز، يعني كيف بستخدمه انا في النت. اقصد يعني لو حطيته مثلا لوكال ما راح يخش على النت عام، ما راح يستقبل من برا، ما راح يرسل الا بس لوكالي.
نعم، أي internet connection through the global unicast address. Locally, you will use the local link address. نعم.
يعني يحدد مصيره بالمصطلح العربي، يعني الادرس حقه.
لا، هو راح يكون عنده global ولوكال، ولكن اللوكال is not routable. نعم. أي انترفيس راح يكون له LLA وGUA. نعم. راح تشوف الآن راح نصير نحط 2 IP للديفايس. الآن راح نسوي configuration. نعم.
أوكي.
الآن حتى لو ما عندي global، انتبه. If I do not have a global, I can have a local. I can connect with the devices within the same link by using the local link address. تمام؟ يعني مش شرط يكون عندي global عشان يكون عندي local.
اوكي.
طيب الآن الconfiguration. Simply same commands we have discussed to configure any IPv4 devices. The only difference, instead of using IPv4 word, what we will use IPv6. So most IPv6 configuration and verification commands in Cisco similar to those used for the IPv4 counterparts, the previous parts. In many cases, the simple difference, what we will use IPv6 instead of IB. We was using the IB, sorry, not 4. So the command to configure IPv6 global global unicast address on the interface is what? On the IPv4, it was IB address followed by the address and the subnet. What we will do here? Simply IPv6 address followed by the address and the prefix. There is no subnet notation, prefix. So example, we want to allocate to the gigabit Ethernet 000 a global unicast address. Interface gigabit Ethernet 0000. We access the interface mode here, the sub mode. IPv6 address. This is the IPv6 address. As you see, 2001. From this one, from the first hexet, it's very clear it's a global address. So we have assigned the global prefix address. No shutdown. Activate the interface. Exit the configuration mode or the interface configuration mode. Done. So what's the difference between 4 and 6? Only this line. Also, we can configure manually from the interface, IP interface, GUI, manually configuration the IPv6 address on the host. It's similar to the configuration of the IPv4 address. Right-click, TCP properties, we can select or we can fill the required details. So the global unicast address or local unicast address of the router interface can be used as a default gateway. Now we need to assign a default gateway to the host. The default gateway will be what? Global unicast address of a router interface, or it can be the local unicast address, local link address of the router interface. They can be used as what? As a default gateway. But the best practice is to use what? The local link address of the router as a default gateway. Use the local, not the global. But we can use any of them because both of them will be assigned to the same interface. So we can use the GUI configuration. Here we have selected the IP address, subnet is 64, the default gateway, the address is 10 here, the default gateway is 1. So a local link address of the what? Router interface. Now DNS also, it can be configured manually or it can be obtained automatically. Domain name services. Do you know what's the DNS? Why we need it? Why we need a DNS? Why we need a DNS? DNS ايش هذه يا جماعة؟ أعطونا جواب بالله. Can you hear me?
نعم.
طيب ايش الدي ان اس؟ قولوا we don't know dynamic name system, dynamic name services او system. طيب انا ما بدي اختصارها يا اسماء، بدي اعرف ليش محتاجينها. طيب we have a google.com, right? yahoo.com, Gmail, we have Arab Open University.
انا اتذكرت الان.
We do not have names. We need to map the name to actual what? IP address. The computer dealing with the numbers يا جماعة.
تحويل الاسم إلى تحويل الاسم إلى الاي بي.
Thank you. والعكس صحيح. والعكس صحيح. اوكي؟ بدون دي ان اس ما بنقدر نتواصل مع النتورك يا جماعة. طيب. الآن when the DHCP dynamic host configuration protocol, now the DHCP can assign what? We can obtain IP address, whatever we need from a server by using the DHCP server dynamic host configuration protocol. When DHCP version 6 or stateless address auto configuration is used, the local link router will be automatically specified as a default gateway address. What do you mean by this? I will explain it. We are coming to this part, stateless, DHCP, stateful DHCP, stateless address auto configuration. We'll come to these three modes in this class. Now, configuring the local link manually let you to create an address that is recognizable and easier to remember, even if you do not want to generate. If you want to configure your interface manually, assign a specific local link address to your interface manually, we can do this by using the command IPv6 address. Then we can write the IPv address, the local address, so it should start with FE80, let me say. And at the end, we will add another argument, local link. So same configuration as the global, but what we will write, IPv6 address, then the address, the local link address, followed by local link. So this is my local link address. Also, for the same interface as you see, لاحظ لنفس الانترفيس, local link and global unicast. No shutdown, activate, exit. So the same local link address can be configured. Also, the same local link address can be configured on each link as long as it's unique, which means I can use this local link address on a different link. What I mean by different link? Same address can be used by... لا ركز بسؤالي, هذا local link same address can be used on router 2 on a different link. ايش يعني؟ same address can be used on router
يعني
2.
الانترفيس الجهاز اللي معاه حياخذ نفس اللوكل.
انا ايش قصدي بلوكال لينك؟ ما انتم ما بتركزوا. سبنت ثانيه. So we can use the same local link address for a different interface on different link on different subnet. تمام؟ لأنه هذه subnet وهذه subnet ثانية. أوكي؟ وصلت؟ هذا سؤال TMA هذا. مطلوب منكم تسووا configuration ل IPv6. Any question? طيب الآن now devices can obtain the global unicast address dynamically. We can obtain IPv6 not manually. Configure it by using the ICMP, the Internet Control Message Protocol version 6. Now ICMP messages can be divided into two groups, let me say. So any device can obtain a dynamic address through the ICMP version 6. IPv6 routers periodically also any IPv6 router will send out the Internet Control Message Protocol version 6 router advertisement messages every 200 seconds by default to any enabled device within the network. Now, router advertisement message will also be sent in response to any host sending router solicitation message, which is a request for router advertisement message. Now, why we need the ICMP? To obtain an IPv6 address dynamically, okay? Now, in case as a device I need to obtain an address dynamically, I will send a message to the router called what? Router solicitation message. So router solicitation message sent by the host device to discover the IPv6 routers. Router will reply to the router solicitation message by sending back the router advertisement messages. So router advertisement message sent by the router to inform the host how the host can obtain a global unicast address and will provide useful information such as network prefix and the prefix link. So network prefix will tell the device which network the devices belong to. Default gateway address, and the default gateway address, according to our discussion, will be the local link address of that router. The router response, reply, the router solicitation message. So the source of the RA message will be what? The default gateway address. Now DNS address, domain name service or server addresses and domain name. It will be also an information with the RA messages. This one is the addresses of the DNS servers and the domain name servers. So one more time, suppose I am a host and I need to obtain global unicast address dynamically, not manually, dynamically. What I will do, I will send RS message by using the Internet Control Message Protocol version 4. Now router will receive my RS request. Router will send to me RA response or reply. Now this reply, okay, containing information helping me. So this information will what? tell me as a host how I will obtain a global unicast address. What's my network prefix? What's my default gateway? What's the address of the DNS? Now, please focus here. Router advertisement messages can use one of these three methods in order to provide the node with the information needed. We can use one of these three methods: stateless address auto-configuration, stateless address auto-configuration with DHCP server, stateful DHCP server, no stateless address auto-configuration. It's before I continue وراح أزيد شوي بالسرعة لأنه ساعة راحت الآن. Is it clear what's the difference between RS and RA? We need to obtain a global unicast address. We will send RS message to the router as a device. Router will give me the information. Now, stateless address auto-configuration allows the device to configure a global unicast address without the service of the DHCP. Request any information from the DHCP server. Devices will obtain the information they needed to configure the global unicast address from the router advertisement message of the local router. What does that mean? Stateless address auto-configuration will give the host all the information needed to obtain a global unicast address without connecting the DHCP server, without requesting anything from the DHCP server. So the prefix is provided by the router advertisement message, and the device will use now either extended unique identifier or a random generator method to create interface ID. What does that mean? After the device receives the RA, now the device will know what's the prefix. So we need to combine the prefix, which is a 64 here, with the user ID to have our interface ID MAC address. How we can generate the interface ID? We have two options to generate an interface ID. We can use something called EUI64, Extended Unique Identifier, which is a method will be used to automatically configure the IPv6 host address or generate an IPv6 address. Or we can use a random generator. Random. Select any random interface ID values. Okay? So, on the stateless address auto-configuration, the process like the following. The host will send RS message to the server. Can you give me the details I needed to obtain an IPv6 unicast address? The router will send back RA. I have everything you need. This is the prefix length, default gateway, address. So no need to have any communication between the host and the DHCP server. Now the second method, stateless address auto-configuration and the stateless DHCP. Now what will happen here? The router advertisement message will instruct the device to use both the stateless address auto-configuration and the DHCP. So RA message will give the device the following, or will suggest the device to use the following. We will use the stateless address auto-configuration to create our global unicast address, local link router with the RA source IPv6 address as a default gateway. So we'll have the GUA, the prefix, the gateway address. But what we need, we still need the DNS. We need the DNS. So stateless DHCP, Dynamic Host Configuration Protocol server, will be connected to obtain information such as the DNS address and the domain name. So let me explain it here. The host will send RS message. This PC will send, I need address information. Now this router will send RA. The router will send RA message to all nodes within this method. Stateless address auto configuration, stateless DHCP. This is your prefix. This is the prefix link. I am your default gateway as a local link address, but you need to get the DNS information from the DHCP server. So the host will connect the DHCP server or will solicit the DHCP server to get the details about the DNS. So everything is provided except of the DNS information in this case. So the host will connect the DHCP server. While in the previous one, everything will be provided from the router as an RA message. واضح الفرق؟ واضح؟
يعني الدكتور اللي قبل كان ياخذ كل شيء من يعني المعلومات ياخذها من الراوتر.
من الراوتر. الآن هنا قلنا له هذا البريفكس، هذا البريفكس لينك، هذه الجيت واي، ولكن لو سمحت تواصل مع الدي اتش سي في سيرفر عشان الدي ان اس ادرس. تمام؟
اوكي.
طيب. Stateful DHCP. Everything will be provided from the DHCP server. So stateful DHCP is similar to the DHCP in IPv4, Dynamic Host Configuration Protocol. So the device can automatically receive a global unicast address, a prefix link, addresses of the DNS from the DHCP server. So the process is like the following. The PC will send RS message, I need address information. The router will send RA message to all nodes with method 3. What's method 3? Stateful DHCP. I am your default gateway. I am your default gateway as a local link address, but you need to ask the DHCP server to get the additional information, prefix, prefix length, DNS addresses. So the PC will now send solicited message to the DHCP server. I receive my default gateway. Please provide me with the additional information I needed or the addressing I needed, and it will be provided from the stateful DHCP server here. Only the gateway will be provided in this case. So the message suggests the device the following. The router local link address is used for the default gateway address. Any other information will be obtained from the stateful DHCP server. واضح؟ طيب, now let us move back or let us focus in method 1 and method 2. Now in method 1 and method 2, the device can obtain a global unicast address, right? But in method 3, it should be provided from the DHCP server. So when the RA message, remember, RA message sent by default from the routers every 200 seconds to all nodes within that local link, by default, like this. When the RA message is either stateless auto-configuration or stateless auto-configuration with a stateless DHCP, the client must generate the interface ID. How the interface ID can be generated? I told you we have two methods. The first one, it can be generated randomly. The second method, it can be generated by using EUI, Extended Unique Identifier method. So interface ID can be created by using the Extended Unique Identifier 64. Or it can be generated randomly. I'm talking about this now. Just 64 bits. So how it's generated? How? It's very simple. Just focus with it. The IEEE, Institute of Electrical and Electronic Engineers, defined the EUI standard or modified the Extended Unique Identifier or modified Extended Unique Identifier 64 process. Now, how the 64 interface ID will be generated? It's very simple. 16 bits value, and always the 16 bits value will be FFFE in hexadecimal, will be inserted in the middle of the Ethernet MAC address of the client. Now we have an interface on the client, right? Every interface will have a unique MAC address. What's the size of the MAC address by default? 64 bits. So what we will do to make the 48, what we will do to make it a 64 bits, we will add or insert in the middle 16 bits, 4 hexadecimal values, always the 4 hexadecimal value FFFE, always. So what will happen in this case? In the middle, so 24 bits MAC address FFFE and another 24 bits. So this is step number 1. Now this is the MAC address. Now what we did, 24 bits, another 24 bits. What we have added between them? FFFE value. Now step 1. Step 2. The bit number 7 on the first hexet is reserved. What does that mean? If the bit number 7 is 0, it will become 1. If the bit number 7 is 1, it will become a 0. واضحة? So, take the MAC address, add in the middle FFFE. This is step 1. Step 2, check bit 7 on the first hexet. If it's 0, it will become 1. If it's 1, it will become 0. So what it was, now this one is the first one, FC. Now, what's the value of F? Let me here explain it. What's the value of F? F1111. Now C, A, B, C, 10, 11, 12. So 1100. Okay? Now, where is the bit number 7? This is before. Now, where is bit number 7? This one. So it will become 1111, 11. Sorry, or let me add a space. 1110. What's the number? F. Now here is what? 8 plus 4 plus 2. E. So bit number 7 will become E or an E. واضح? So what is this? Extended Unique Identifier method to generate what? User interface address. واضحة؟ طيب. Interface ID also can be generated manually, can be generated randomly. Now check this one. What is this? This is the global unicast address for that interface. What is this? The local link address. Do we have the form FFFE in the middle? Do we have FFFE in the middle? No. So the local link address generated, or sorry, the interface address is generated here, what? Randomly. It's generated randomly. It's started from here, from this 5. Now, to make sure when we generate an IPv6 address, it's a unique IPv6 address, the client might use a process called duplicate address detection, DAD. This is similar to the ARP request, address resolution protocol, for its own address in order to make sure that the address is unique and it's not reserved by any other device within the same link. Now let us take another example, or we will see another example later on to know why. Now this one is what? Generated randomly. Do we have FFFE in the middle? No. This is how we know. Now let us talk about the dynamic link address. Dynamic link address, or any enabled device, must have a dynamic link address to connect it with the same link. It can be configured manually or automatically. So like the IPv6 global unicast address, local link address can be configured dynamically also. Now the configure shows the local link address dynamically. Use it by using the address FE80. This is what the local link address range. So it should be within this range and the prefix 10, for example, here. Prefix and interface ID can be generated by using EUI process. So even for the local link address, let me simplify it to you. We can use a random generator for the interface ID, or we can use the EUI64. So it can be manually or automatically. Now, which one here manually, or which one used EUI, and which local link address here used the random generator? Now check this one. This is the local link address. What we have in the middle? FFFE. So local link address interface ID was generated by using the EUI64 method. Now what about the local link address here? How I know this one is the local link? FE80. FE80. And as you see, the interface ID is same for the IPv6 address and the local link address. Same interface ID. But what's the difference here? Here we are using the prefix address. Here we are using what? The local link prefix address. Gateway, local link, number 1. So here we have a random interface ID generator. Here we have used or implemented what? The extended unique identifier. واضحة? So for example, here also we have using what? Extended unique identifier. واضح؟
واضح يا دكتور.
Be careful. كثير multiple choice questions على الاي IDs. ممكن نعطيكم الماك ونقول لكم كيف صار الاي يو اي. ممكن نقول لكم هذا generated randomly ولا generated باستخدام الاي يو اي او الراندوم جنريتر. فلازم نكون فاهمين الاي يو اي كيف تشتغل. هذه طريقة الأسئلة. tricky like this. Now Cisco routers automatically create an IPv6 local link address whenever, automatically, whenever a GUA, a global unicast address is assigned to the interface. By default, Cisco IOS routers uses the AUI64 to generate interface ID for all local link address on the IPv6. So even the routers will use EUI as a default method to generate a local interface ID. What we have here, an interface ID generated automatically by using EUI methods on router interface 000. Now, please refer to this on the Net Academy and see how we can verify the address configuration. Show IPv6 interfaces brief. There is an activity on the Net Academy, videos as well. I added only the comments to know what's the comments we are talking about. Show IPv6 route Bing comment. Now let us talk about the multicast addresses. IPv6, we have a unicast, we have a multicast address. Multicast addresses have the prefix FF00 with a prefix 8. And the multicast addresses divided into two types of addresses. Well-known multicast addresses, solicited node multicast address. Now, multicast addresses can only be a destination address. They cannot be a source address at all. Only a destination address. So, when we assign a multicast address are predefined, or the multicast address for a predefined group. What's the benefit? If you use the address for a group of devices, we can communicate all of these devices by using a single multicast address. So we can reach a group of devices running the common protocol or service by using the multicast address as a common address for all of these devices. Usually, we assign the multicast address for a specific protocol. For example, for the DHCP version 6, we can use the multicast address where we might have a different servers providing the DHCP service. Now, well-known multicast addresses are assigned and reserved for a predefined group of devices. We have said we have well-known multicast, we have solicited node multicast. Well-known reserved for specific or predefined devices. In general, we have two common multicast group. First one, FF002, ended with 1, which means all nodes multicast group, all node. This is the multicast group that all IPv6 enabled devices will join. So this is the multicast group. Any end device can join it. So the packet sent to this join is received by and processed by all the interfaces on this multicast group. واضحة؟ هذا الأدرس للمulticast group. Any device within this group will receive the multicast message and process it. For all nodes here, F002 end with 2 address all routers. This is the multicast group that all IPv6 routers join. Routers become a member of this group when it's enabled the IPv6 router with an IPv6 unicast routing. So how we can make the router join this group? It will be by default. Router will join or will become a member of this group after we enable the IPv6 router. How? By using this command, IPv6 unicast routing at the global configuration command. So enable the unicast address on the router IPv6 unicast routing. Where? At the global configuration mode. Done. We did the process. So this is the well-known multicast. What about the solicited node multicast address? Solicited node multicast addresses is similar to all nodes multicast address. All nodes multicast. Solicited node multicast address is mapped. This is the only difference. It maps to a special Ethernet multicast address. So we have all here, solicited node, one to many. Now, what's the difference? It will not be processed by all the PCs here for the IPv6. Now, the Ethernet, because we said it's mapped to special multicast address, the Ethernet network interface card can filter the frame by examining the destination MAC address without sending it to the IPv6 process to see if the device is intended a target for the IPv6 packet or not. For example, here we send solicited node. It will be examined at the Ethernet. First one, my Ethernet network interface card, it's not for me. Examining the NIC, it's not for me. Last one, it's for me. I'm within this one. So it will be processed later on or sending to the IPv6 process. So this is the only difference. Now for the subnetting, IPv6 was designed with a subnetting ID in the mind. Now we talk about the fields: global routing prefix, interface ID, 16 bits, and it's recommended in this way to be for the subnet ID. So a separate subnet ID field in the IPv6 global unicast address will be used to create subnets. The subnet ID field is the area between global routing prefix assigned by the ISPs. It can be in any prefix, but it's recommended to use 48. We can use 32. We can use any other prefix. So global routing prefix plus the subnet ID should always equal 64 bits. Now, how we can have a different subnetting? For example, if we have this, a global prefix address. Now we can use 16 bits for the subnet ID because only is 48. The prefix is 48. So we can have subnet 0, 1, 2, 3, 4, 5, 6, 7. We can go along with these 16 bits. This one is a hexet, 16 bits, till we reach FFFF, all ones. So we can have 65,536/64 subnets. Why /64? 48 plus 16/64. So per subnet, we can have 2 to the power 64 interface ID, let me say. So the global routing prefix is same for all the subnets. The global routing prefix is same as well. Only the subnet ID will be incremented in each hexet. Only, as you see, the subnet ID is the different. A global prefix ID is totally unique. Do we need to have a variable length subnetting mask here? No. Let us take an example. Suppose we have this topology. We have this topology, so we need 5 subnets. 1 for each LAN, 1, 2, 3, 4, and we need 1 for the serial between router 1 and router 2. So simply we can allocate or we can assign the first 5 subnets to every one. So subnet ID 1 will be for LAN 1, 2 for LAN 2, 3, 4, 5 between the routers. So we have used 5 subnets from the total available subnets, which is 65,536. What we have changed here? Only the subnet ID. Subnet ID 1, subnet ID 2, 4, 5, 3. So simply we will change the ID. We will keep the global prefix same for all the subnets. Now this example shows that each router interface on the router 1 has been configured on different subnet. We have interface gigabit 000. This is the IP address, and as you see, we have used subnet 1. For interface 001, the subnet ID is 2. For interface serial, the subnet ID 3. And so on. Different subnets for different interfaces. Any question? We are going to start with the next module 13. Just let me share the screen. لا ما خلصنا الله يرضى عليكم، ما خلصنا. معروف 2 modules per meeting. الآن الموديول هذا قصير، يعني أقصر، وإن شاء الله إنه أسهل. لحظة بس. طيب. Now what we will talk about the Internet Control Message Protocol. Remember, we have what? Send router solicitation, router advertisement. So we'll have additional services here. So let us talk about the ICMP message. Why we need it? The main purpose of these messages is to provide a feedback about issues related to the processing of the IP packets under certain condition, not to make the IP reliable. So, Internet Control Message Protocol provide a feedback about issues related to processing the IP packets under a specific condition. It's not to make the IP reliable. Now, ICMP version 4 is the messaging for the IPv4 protocol. ICMP v6 is the messaging for the IPv6 protocol. Now, both includes additional function. Now, what are the common messages function for both? We have some messages with common function for 4 and 6. As you will see, we will talk about the host reachability. ICMP messages is common for both 4 and 6, including a common messages. Some messages will be used to check what? The host reachability, the ping, another way. Destination or service unreachable, it's a common message. Time exceeds, it's a common message for version 4 and version 6. Now, ICMP v4 messages are not required and are often not allowed within a network for a security reason, but we will talk about it. Now, host reachability, how it will be checked. The ICMP echo message can be used to test the reachability of a host on an IP network. Simply, the use of the ICMP echo message is the basis of the ping utility. Now, H1 want to check if H1 can reach H2 or not. So H1 will generate or send an echo message, ICMP echo message. If it's received and H2 is alive, operate without a problem, H2 will send back echo reply to H1. So the connection between H1 and H2 is what operates successfully, host reachable. So in this example, the local host will send the echo message request to that host, to the other host. If the other host is available, the other host will send what? Echo reply. Now, it's the basis of what? Bing command. You know what's the Bing command, right? Bing followed by the IP address. Now, ICMP destination unreachable message can be used to notify the source that the destination service is unreachable. So here we'll check if the host reachable. Here the host is unreachable. ICMP message will include a code indicating why the packet could not be delivered. In case we have destination service unreachable, we'll have a code on the message. This code will indicate why the message could not be delivered. So when we talk about ICMP v4, following are some codes can be used in the message. 0 means the network is unreachable, 1 host unreachable, 2 protocol unreachable, 3 the port unreachable. For ICMP v6, we have some different codes. 0, no route to the destination. 1 as a code means communication with the destination is administratively prohibited. There is a firewall. The echo request blocked. 2 beyond the scope of the source address. 3 address unreachable. 4 port unreachable. Now, what's the common message between both of them if it's a question? This is the common. Host reachability, destination, time exceeds. Now, what about these? The codes for the service unreachable, the common message too. Now, ICMP v6 has a similar but slightly different codes for destination unreachable message. Now, time exceeds. When the time to live TTL fields in the packet decremented to 0, no more hubs is available. So the ICMP version 4 time exceed message will be sent to the source host, which means the router will discard the packets and the router will send ICMP time exceed message to the source host. For ICMP v6 also, they send a time exceed message, but instead of that, instead of the IPv4 time to live field, what we have used, we talk about this, by the way, when we talk about the headers. ICMP v6 uses what? The limit hub or the hub limit field. If it's reached 0, times exceeds, no more hubs available, so we'll send what? ICMP message to the source. Now, times exceeds message are used by the traceroute tool, and we'll see an example on the last slide. For example, here what we have Bing comments with this IP 8.8.8.8. For example, Binging. Now we have received a phase 1, so it's expired in a transit. Sorry. Reply expired. expired, 4 sent, 4 received, 0 lost. No, all of them already what? Sent successfully, and we receive sent 4 packets, received 4, lost 0. The percentage of the loose packets is what here? 0%. Now we'll talk about it in full details. Just we need to know what's the messages and what's the type. Initially for the ICMP version 4 and 6. Now, here also if we talk about the router, if the router receives a packet and decremented the time to live to 0, so the time the TTL on the packet becomes 0, what the router will do simply discards the packet and send time exceed message to the source. Now, how the time exceeds message are used? We will use the trace route tool. What's the trace route tool? This is what we will talk about it now in this coming part. Now, keep in your mind that ICMP version 6 has a new features and improved functionality not found in version 4, including 4 new protocols as a part of neighbor discovery protocol, which can be written as ND or NDP, Neighbor Discovery Protocol. What I'm talking about, router solicitation message, when we talk about obtaining the global unicast address, and router advertisement message, we have neighbor solicitation message, neighbor advertisement message. So this is the main 4 new protocols used in ICMP version 4, but they are not available in ICMP version 4. Not available in 4, available on version 6. Now, any messaging between a router and a device, including the following: router solicitation message, router advertisement message. And we already discussed it for the stateless address auto-configuration, with a stateless DHCP, and so on. Now, messages between IPv6 devices, including duplicate address detection, the DAD, and address resolution process, including neighbor solicitation message, neighbor advertisement message. ICMP version 6 also include redirect message, which has a similar function to the redirect message on version 4. Type now, so when we talk about the router advertisement message, as we have said before, the node will request some information from the router, so router solicitation, router advertisement will be sent from R1 to the PC1. So RA messages are sent by the IPv6 enabled devices every 2000 seconds to provide addressing information to any enabled IPv6 version 4 host, version 6 host. The prefix, prefix link, gateway, DNS services, for example. So this is the router advertisement message. RA message can include the address information, prefix, prefix link, DNS, and domain name. We already talked about this. The host using the stateless address auto-configuration will set its default gateway to the local link address of the router that sent RA. Now this router interface sent the RA to this PC. So the default gateway will be the local link address of R1 in this case. It's a revision يا جماعة الكلام اللي غطيناه سابقا. Also, IPv6 enabled routers will also send out router advertisement message as a response to any router solicitation message. So it can be sent periodically to all enabled devices every 200 seconds automatically, or the message can be sent as what? As a response to RS request. So in this example, BC1 sent router solicitation message. I need an information. So router 1 will send RA message. BC will say, for example, I just put it now, I need an information to get IPv6 address. Router 1 will send RA reply. Here is your global unicast address, prefix. The prefix length is here. In this example is 64. I am your default gateway. This is the DNS information you needed. So whatever you want can be provided from the router in case we are talking about the stateless address auto configuration here as an example. So whatever the device is needed will be provided from the router. Now, the device assigned the global IPv6 unicast or local link address, the device will generate the user or the interface ID, let me say randomly. So the device needs to check, is this random interface ID reserved by any other host? How we can check the uniqueness? We will use the duplicate address detection. It's similar to the ARP request to ensure that the address is unique. So the BC will send neighbor solicitation message. If none of the other devices send neighbor advertisement, means this ID is unique, can be used. If the device received any neighbor advertisement response, the device will what? Change the randomly generated interface ID in this case. So to determine the MAC address also for the destination, sometimes we need the MAC address, but we have the IP, so address resolution. The device will send neighbor solicitation message to the solicited node addresses. The message will include the known target IPv6. The device that has that target IPv6 will send a response with neighbor advertisement containing its MAC address. So for example, BC1 needs the MAC address of the router. BC1 will send neighbor, it should be a different device, not the router, or the router. Neighbor advertisement message, or sorry, the router here requesting the MAC address of the BC. The router knows the IPv6 address. So the router will send the neighbor solicitation message. BC1 will respond by using neighbor advertisement message. So router can get the MAC address of BC1 in this case. So in this figure, router send the neighbor solicitate to this address. So it's the address actually of BC1 asking about its MAC address. BC1 will send back the neighbor advertisement message providing router 1 with a MAC address details. Now what we have discussed here, the type of the message, the type of the services can be used on the Internet Control Message Protocol. Now let us move back to the process of testing the connectivity. Bing is used to test the connectivity. Bing simply, it's a command in IPv4 or IPv6. Testing utility that uses the ICMP echo request host reachable and echo reply messages to test the connectivity between hosts and provides a summary including the success rate average, round trip time to the destination. What's the round trip? The time needed for the packet to move from the source to the destination and to be sent back from the destination to the source. So here, for example, S1 Bing 192.168.20.2. So we have here the details. The success rate is 80%. 4 out of 5 packets sent correctly, responses sent back. Round trip time is 1 milliseconds as a maximum. Minimum, average, or maximum. So 0 is the minimum, 0 max, average, 1 is the max. If a reply is not received within the timeout, Bing provide a message indicating that the response was not received. Now, it's usually common for the first Bing command to reach the timeout. It's common for the first Bing to time out if the address resolution, ARB or neighbor, discovery protocol need to be performed, before we sending the ICMP echo request. So what we will use to test the connectivity, a Bing command. If the host at that specified address receive the echo request, it will respond back with the echo reply. As echo reply is received, Bing will provide a feedback about the time when the request was sent and when the reply was received. So this is the time, the round trip time. It can be used to measure the network performance in this case. If we do not receive any echo response in this case, the Bing will indicate that the response was not received. It may indicate that there is a problem, or sometimes it can be a security feature. What's the security feature? Simply network administrator disabled, blocked the Bing traffic. So we cannot ping the device. The Bing will not be sent successful in this case. Now, Bing can be used to test the connectivity with the device internally as well. So can be used to test the internal configuration of the IPv4 or IPv6 on the local host. As a local host for IPv4, what we can use, which IP address? 127.0.0.1. If we are going to ping the local host for IPv6, we can use all zeros, the last one, local link or stack address, local host address. So the device can ping itself in these two addresses. The response from 127.0.0.1 for IPv4 or ended with 1 for IPv6 indicate that it's probably installed on the host. Error message indicating that the TCP IP is not operational on the host. So what's the benefit of a local host pinging or the loopback pinging? In case response is not received, it means that the TCP IP on the host is not operational and it has a problem. If we receive the response without any problem, it's confirming that TCP IP is installed and working on the local host. This is the main goal of what? Of being the loopback address. TCP IP installation and working confirmation. Now also we can ping the default gateway to test the ability of the host to communicate on the local network. The default gateway address is most often used because the router is normally always operational. Usually we use the gateway because by default the network always is up and operational. Successful ping to the default gateway indicate that the host and the router interface serving as a default gateway are both operational on the local network without any problem. If the default gateway address does not respond, the ping can be sent to IP address of another host on the local network that is known to be operational. Now, I have a simple question here. Suppose we try to ping the default gateway and we did not get a response from the default gateway. We know another local IP address for host C. Let me see. We ping host C, send the response, the connection is okay. Is that means we have a problem with the gateway? Is that means we have a problem on the gateway interface? مرة ثانية, I tried to ping a PC, ping without any problem. Trying to ping the gateway, a connectivity problem. So what we can say in this case, sometimes, maybe, okay, a wrong default gateway address has been configured on the local host. So this is one of the possibilities. Another option, it may be that the router interface totally operational without any problem, but we have some security measurement applied. For example, we are blocking the ping request between the hosts and the router as a default gateway. Also, we can ping a remote hosts, so the ping can also be used to test the ability of the local host to communicate across the internet. A local host can ping a host on a remote network, successful ping across the internet confirming the communication on the local network. Many network administrator limits or prohibited the entry of ICMP messages. Therefore, the lack of ping response could be due to the security restrictions. And this is actually the default. It should be blocked in order to maintain the network performance to the best. Type two more slides. Okay, two more slides. What's the trace route? Trace route simply it's a utility. It's a utility that generates a list of hubs that were successfully reached along the path. So this list will provide important verification and the troubleshooting information. If the data reaches the destination when we use the trace route, then the trace list the interface of every route in the path between the hosts. If the data fails at some hops at the long way, the address of the last route that responded to the trace route can provide an indication about where is the problem or some security restriction. What does that mean? We know that when we send a message, it will be routed through multiple routers until it reaches the hosts. How we can trace each route? How we can trace each route? We will use the trace route. Trace it tool or utility. So, for example, if we write this trace route 192.168.40.2, we will have the trace route table in case we reach the destination or an information about the last hub. So the first hub, it will be 192.168.10.2. It takes 1 millisecond as an average. Now, next hub, 192.168.20.2, 2 milliseconds. Next one, 30.2. Last one, 40.2. So we have reached our destination. We get information about the data path or the path on every interface router. So the interface router 1, let me say 2, 3, 4, for example. So this information can help us for troubleshooting or verification of our network. For example, if we receive a message or we only stop here, so I will know or we can know that the problem started after this interface when we trace route our message. So trace route provide route trip timer for each hub. So from the source to router 1 millisecond, from the source to router 1, then 2, it takes 2 milliseconds. Source, router 1, router 2, router 3, then router 4, and so on. So it will provide information for each hub along the path and indicate if hubs fails to respond. *X here is used to indicate the lost or unreplied packets. This information can be used to locate a problem router in the path or may indicate that the router is configured not reply. Now, the trace route makes the use of a function of the time to live field in the IPv4 and the hub limits on the IPv6 in the layer 3 headers, along with the ICMP times exceeds message. Now, let us assume we need to trace the path from this PC until the destination. So from 10.0.0.1 to 192.168.1.2. Now, what we will use the trace route with time to live field. We are using IPv4. Now, on the first message sent from the trace route utility will set the time to live field to 1. So the first message we will send it, the TTL value will set to be 1. This will causes that the TTL to the timeout, TTL will become a timeout at the first router. Now TTL is 1. We send the message will reach router 1. Now the TTL will be decremented by 1. So it's 0. So router 1 will send what? Will send what? ICMP version 4 timeout exceed message. What does that mean? The path between the local link and the first router's interface is working without any problem. Now trace route will increment the TTL by 1, so the time to live will become 2. So we'll send a message now. From local network to router 1 interface, the time to live is set to 2. It will become 1. From router 1 to router 2, now the TTL will become 0. Here we subtract decremented by 1, decremented by another 1. So at this router interface, the DTL becomes 0. So what this router will do? Discard the packets in ICMP version 4 time exceeds message to the source. So what does that mean? It's indicating that the path to router 2 interface is working without any problem. Now the TTL will become a 3. So 1, 2, 3. Here the TTL will become 0. We will receive what? ICMP message time exceed. Now next time the TTL will become 4. So 1, 2, 3, 4. We will receive ICMP now here. So we have tested the path along all the routers interfaces between the source and the destination in case the TTL equal 4. So trace route will increment the TTL fields to be 3, 4, 5, and so on for each sequence of messages. This will provide the trace with the address of each hubs and the packets time out further down the path. The TTL fields continue to be incremented until the destination is reached. So here we reach the destination when the TTL becomes 4, or it will be continue to be incremented up to the predefined maximum TTL amount. Now this is the end of module 13. Before you leave, I would like to remind you with something.